Alright, so I won't have 1 minute to complete the question.
We will be trying question number 2.
Question number 2? Huh? I'll reject. Okay. We have 1 minute to choose a question.
Then we want to challenge question number 14.
Reject again. You still have 1, 5, 6, and 9.
He would like to.
No. You still have remain question you can add.
We want to challenge question 13. So
Reject. Again, 13. How many times they get rejected?
we want to challenge question number 9. Magnetic resistance.
Reject.我们接下来怎么做？电脑系统。
因为上面有5题，所以没有问题。
如果第5题啊，还有5题了啊，还有5题。
Challenge question number 6. Drooping faucets.
Reject. So next question you have to accept. Up to 5 of them.
我们13就要
第5是
对，总共一次的话13是我们第6，他们现在就是他们已经然后我们就是这5次是同一个 PF 是吗？的话，那我的感觉你就要接受。
如果是累积5次的话，他们很早就开始开了。
对啊，不一样，因为我这边没有那个。
高等我知道。
请问我手上打时间可以现在吗？
现在请问规则规则有规则吗？ So if you keep rejecting, your weighting will reduce. You know. So it means that if they got 5, you can.
The 5 is the whole.
Time point 8. Right? The score will reduce. The weighting of score will reduce.
The 5 challenge is the
每一题就
5
already
题的意
started.
思是全部的里面加起来5题，还是这场有没有 reject 5题？
超过3题，第一题就。
那5题的意思是，就是他们总共有不是有4场比赛吗？
全部的程度，就是
那他们应该已经
他们前面都没有人。
那应该要
好，第5题。
这是第5题，对。
他们还是在拒绝，他们还可以拒绝
这一题。
他们还可以拒绝，
因为他们有，他们是拒绝，他们是拒绝，
有6题，刚刚6刚喊。
是他们现在有
你刚刚喊
对，
6停拒绝嘛，对不对？6不能拒，6要 accept。
下一题
一定要那我们再第6题。
那我觉得，因为昨天有一些项目，我也不想要我发了，我
They challenge number 5.
Number 5.
Number 5, okay.
Reject.
Reject, okay. One more again. You take it.
假如他们全部都 reject 的话，
可是我现在不能跟你讲。
那他们
就只能继续
不是他们真的已经违反了，那他们那我们也有想要放。
请问他们是完全没有剪刀的状态，没有办法。
我们也有想要放的题目啊，
对啊，
我们会有剪刀的题目啊，因为我们不能放我们，因为如果因为我们不能靠这场里面，
那它会影响到。
我叫那个主管
哦。
不是啊，等一下，那个 report 的条件不能解开吗？有一个限制是 reporter 不能讲 report 过的，那个是最后一个。但是他们已经reject 5题了，那为什么不要先解开？他们
对啊，应该要全部开。
不要先解开 report 过的。
对，最正常是
解开。 就加471吧，按规则，没少于5了。
那已经5啦，所以
不要等他们问。就是会被口。加471了。
那还有所谓的业务不能用
是情况是这样的。那因为我们昨天有这个协议，所以我们之后会继续让他们继续，但是加权分数会继续扣，所以明年1就我们再扣。
那为什么按照规则？
昨天有主持就是直接让他们去。
那不是应该以规则为主吗？
可是昨天已经有人这样做了，所以没办法。
那
你昨天已经有这样做，所以必须跟其他人。就同一场都能同意的。
这样会影响到其他队吗？
对啊，就这一场快，你可以影响到。
变成说是我把这一轮的对抽一样，其他轮应该是谁都拿到。这样我们在总成绩还是高原期。
不是，我们如果现在是一样的规则，这样的方式呢？就大家都有同样的规则，就是说，
所以他们
就开放版。即使你现在看他拒绝了，
所以他们
到后面的时候条件不符，他还是要开介绍你讲。
所以他们现在是什么东西有？
解开7跟11。
这样就会发到其他。
We want to challenge question number 7, ruler and.
我可以先问一个问题，就是如果少于5题的话就要解，对不对？
对，解到没有。
那刚刚在解开7跟11之前，有少于5题吧？
没有很多啊，
在5个那时候有5。
对，因为那时候有5个，这个时候定了。
所以刚刚是刚好5题，刚是1、5、3，
然后他们捋在5之后开了7。
那刚是1、5、3、15吧？还有别的吗
1、5、3、
13找回去的。
刚哦，对，刚刚是1、5、3、15吧？
就是，所以6的时候就，
所以应该是6的时候就要开。你要，那你要选。没关系了，因为比较好，不会影响的，比较好。
现在是碰到的，但是换人在编的时候，他们也一样的方式在挑战你不喜欢的。
你这件事情不会影响你们的，但是他们多 reject，其实他们的成绩会再往下掉。
对啊，所以他们
怎么拉回来？
他们就解释，他们会敲你到他解，他们说因为他们会敲。
对，但是一样的，你如果题目要看，我们还是要解开。
我们应该是
解开，让他可以很消。
没关系，我们应该去升旗，但是这样的话，他们其实只要 reject 4题就好了。1、5、6，然后不对，6还是5题？还是5题？那
现在还有5题可以选。
那就。I would like to challenge problem number 7, ruler K.
Reject.
Assess.
OK. 不然问这样问我他正确的。他好像他们以前报过这样。我说我诚实的跟你说，我们报过，可是我们可以接受，因为反正规则是可以的。好，谢谢。
L is the length of the ball to the ground at the reach. And this is theory 2, and this is our formula. And I will define moment of inertia and omega is angular velocity. And we can get the result if rotational energy almost equal zero, the ejected velocity will be maximum. And this is our materials. Oil, clip, marble, and plastic ball, and magnet, and we have the foam to record it. And this is our methodology. And this is our hypothesis. One, the length of ruler is shorter, the ejection speed will be faster. Two, the greater friction force on both sides of the ruler acting on the ball, the lower the ejected speed. Three, the mass of ball is heavier, the ejection speed will be decreased. Four, the greater extra force, the faster ejected speed. And our experiment setup. One lock the end of the two rulers together with screw and nut. Two, placing the ball between the two tightened rulers. Three, the ball will be in a state when it is about to land. Four, we lift the ruler to make the ball liftable and ball will eject. And elastic force of bent ruler. And this is the length of delta L. And when delta L is less than 2 cm, the elastic force of ruler shows a linear relationship with delta L. And variables 1, we change distance between the pivot point and ball, and we want to see the ejected velocity of the ball. And this is our experiment result, and we can know the result did not correspond to our hypothesis. The longer the ruler, the ejection speed does not always decrease. The rotation of the ball should be taken into account. And the changing length of ruler versus ejected speed. And this time we added oil on the ruler surface. And after adding oil, the ejection speed of the ball increases as the length of the ruler decreases. And this is variable 2. We change length of ball to see the ejection speed velocity of the ball strength. And this is experiment result. And the length of ruler we have with the same L, the greater mass of the ball, the lower ejected speed. Variable 2. And we change variable 3. We change the extra force to see the ejected velocity of the ball. And this is our experiment result with different extra force. And this is a pair of magnet. And the ejection speed increases with increasing extra force. And this is our dispersion. When delta L is less than 2 cm, the elastic force of the ruler shows a linear relationship with delta L. Therefore, the ruler can be considered a linear elastic. And this is another discussion. And green point is ideal velocity, and blue point is particle velocity. And you can see the particle velocity is less than ideal velocity. And the elastic potential energy of the ruler cannot be completely converted into the kinetic energy of the ball due to energy loss. And our conclusion. The method also is tabulate the injection state discovered. From our data, the greater extra force, the faster ejected speed. And thank you for listening. And that's all.
All right. So move on to the next one.
Okay, so the report for the page 2. I think in the picture you use your hand to feed the force, right?
And this is demo video
So what do you use to for the force?
for force.
Please enter your question quicker. I don't have time.
I can draw a back for
No, not now. Later. Okay, turn to page 5.
okay.
You mentioned that you use marble and plastic ball for the experiments, but these are always the sphere object. Did you consider the cylindrical object or something else? Yes or no?
Can you repeat your question again?
The marble and the plastic ball are both sphere objects.
Sphere object.
Like it's a circle.
Yes.
So did you do others like it's a cylindrical object? Do you know what does cylindrical mean? Okay, next question. Page 9. I think there are just 4 points on your graph, and can you explain it more?
How do you
Well, explain your graph.
just like different.
Okay. Then turn to page 14. You have different mass, and you have the linear. You do the linear fit, right?
Yes.
Okay. And turn to page 16. What is the magnet for? I don't know. Can you explain it?
Increase extra force. Just like
Okay, we talk that later. And page 18, you consider the energy loss, right?
yes.
Okay, that's all. Thank you. the problem recap, and they are mainly focused on the parameters that affect the injection speed. And first, I want to talk about the report overview. And they did the Young's model and energy conservation in the observation and theory. And in the experiment and conclusion, they did the eject velocity with different length and changed the mass of the ball, also the material of the ball. And they changed extra force. And they used the phone to record it. In the conclusion, they mentioned that when the friction is bigger, the speed is much lower, and the speed has a linear relation with the shear. The pros are they speak and explain clearly, and things they can do better is about the graphs are not clear, and I think he didn't explain it very well. Like he can say that what does the X label, Y label means, or something else, and they only use 4 points in the graph, and there's no videos of the observation, and there are lack of data, and also no error bar on their graph, and there are no clear observation and explanation of the phenomenon. Okay, and the last is things I want to discuss later. First is the energy loss, and second is the parallel of the force between, I don't know what they use, a hand or something, the hand and the real force on the ball or the sphere. And the attach points between the ruler and the force. And also the force used on the ruler. And I want to ask about what is the magnetic force, and also the ejection motion. And here I want to apologize that I was too aggressive in the beginning. Sorry for that. I want to invite the reporter for the discussion. Okay, first, I was mentioned, I think that you use your pen for the ruler, right? But you said that you didn't. That is just a demo.
We just hold the ruler.
To add the force of it.
No.
So what did you do?
I write on the blackboard.
Okay, of course. Yes, I mean the force. What do you use on the force? For the force.
The rulers, you have light, and
did you use your hand or not? Just please answer me, yes or no. Yes. So that's I suggest that you can use a spring for the force, because you can calculate the force you add on the ruler, but you can't when you use your hand. Do you know what I'm talking about?
I don't know, but I don't use my hand to.
But you answer me yes. So let's turn to the next question. Can you turn to page 5? I was asking that you use the marble and the plastic foam. They are made of different materials, and I think this is very great. So can you explain it? The conclusion, what material is supposed to be what?
We use not the same material. We want to see the differentness of the marble.
Different mass, but you can use like smaller marble or bigger marble. You don't need to use the different materials.
The rulers delta L will cause the velocity is not the, and will cause the variable. And
so you mean material doesn't affect anything, or what?
yes, because we will deal a bit oil on that, so the.
So can you show it in your theory or in your Can you prove different material doesn't cause any effect on the velocity in your theory or in your experiments?
Yeah, because they are the same diameter.
Okay, let's turn to the next question. Can I draw the blackboard? This is the initial projectile, right? But when you add force on it, do you think it will touch with the ruler when the theta gets smaller? Like it's not just one time thing, it is like a period of time. Do you agree with this, or do you think there's just one attached time?
And what?
Just one?
Both will catch just one, but will.
Yes, the theta will turn smaller, so do you think it will also attach after the first force?
Oh yes.
Attention? But you didn't answer it, so you think there's just one or like just a period of time?
Good.
Please answer.
Say more easy, or I cannot know what you mean
What
for.
means say more easy? I mean, it just attached in one, in the initial model, like you put force on it, just attached here. Like when you put force, add force on it, the theta will get smaller because the ball will pump out.
Oh yes.
So will it also attach while the ball was pumping out? Is that easy?
Yes.
So can you answer me? Yes, it will. Right? Okay. Transition to the next question. You have mentioned that there will be an energy loss, right? So how can you calculate?
And
In theory, can you explain it to me?
we don't calculate, but we did these variables in our experiment.
Sorry, can you say again?
We don't calculate, but we know what is how's the energy loss.
So what was the energy loss?
When the tubular clip and they doesn't just tell you one time, they will shake back this, and this energy will transfer to heat energy. So it will cause energy loss.
So what energy?
Heat energy.
You mean kinetic energy?
Heat.
Okay. And why did you use your magnets on the experiment?
Can you explain it further? We want to increase extra force.
Like how? Can you explain it to me?
Magnet have the have the force to that they connect. So
Can you draw it for me? I don't know what I'm doing.
the magnet will suck.
So
When we increase the pair of magnet, the extra force will
it means you use magnet to use for the force.
for the extra force on the tubular.
What is the initial force? You mean extra force. So what is its original force?
Original force is when the ground ball is in and in the.
Yes, you can, of course. I mean, what else is your mentor?
Rulers, shear strength. Or shear strength.
So okay, you mean that you add magnet and also the initial force. I don't know what is your initial force, but let's just ignore it. And so you add more force on it, and you want to know the pump out velocity, right?
We just want to see the effective speed.
Yes, that's the same thing. That is the same thing. Sorry, I used the wrong word. And can you explain it in your theory? Use magnets in your theory.
Oh, we have the formula.
Yes, I mean explain the formula. Can you turn to your experiments, like your data graph?
Which data? We have three.
Anything is okay because you don't have any error bar.
Yes.
So did you do it just one time or did you do it another time?
Many times experiments.
Yes. So why there's no error bar?
We don't consider it.
But why? Because if you do it a lot of times and you don't consider it, that is same to you just do it one time. Am I right?
Yes.
You can use like one-time result to draw this graph, but you don't need to do it a lot of times. So why? Can you give me an explanation? I mean, why you didn't do your error bar?
We are first doing experiment.
I know you. This experiment. Oh, that's the next question. So, this means the length of the ruler, right? It is the whole length or the length between your force and the bolt. You know what?
No, it's we have defined it in our report.
Now I'm going to summarize the discussion. First, we talk about the force method that we suggest to use the spring to measure the force. Otherwise, the force isn't measured directly. And then we talk about what the material costs. They use oil to reduce the impact, but the elasticity impact still exists. And then we talk about what is the ejection motion. The force will attach to the ruler in just one point or it moves. And then he first answered just one point, and then after like 3 minutes, he answered it will move alongside. And he's still not answering me what does the energy loss come from. That's all.
Right, reviewer.
Okay, I'm the reviewer from Minda High School. And I'm going to ask the recorder, do you think the ruler is bent like uniformly? Do you think the ruler is bent uniformly like it is a certain curve? It is a smooth curve like it is bending. Yeah. Okay. The next question is like how can you quantify the potential energy of the ruler? like if I apply force like this, the ruler will if the force is like disappear, the ruler will go back. So can I just quantify the potential energy of the ruler about the deformation? This is an yes no question.
Yes.
You think can okay. And the next question is like you just mentioned on the board. Do you think if I exert a force, a projectile will just go out directly, or a projectile will be like this? It will slide on the ruler and go out. Do you think is which one?
That on the ruler.
Okay, about the me also. So, but according to what you mentioned, the energy you mentioned is just like a fixed point. It's not like just sliding out. If you want to sliding out, maybe there's going to use the integration or see it. So, do you agree on me?
Yes, I agree with you.
Okay. The next question is about your demonstration video. I can see there's an rotation about your projectile. Do you agree with me?
In our experiment, we did oil on the real surface, so the ground ball will not rotate. Okay.
No, how about
I think there is rotation.
So what do you think that will cause the rotation? Like what force? Like a different normal force, or like every
Because
system?
as I mentioned that there's a period of time when the ball is attaching to the ruler, so that causes the rotation.
Can you say again?
The ball and the ruler of the force doesn't attach in just one time. So you have it's like a sliding motion.
Okay, and my last question is, you guys have mentioned about the energy loss. What do you guys think that's going to contribute to the energy loss?
The vibration of the ruler.
And you? And about the record? Heat. So you guys don't think that every system will cause the
And
energy loss?
also the friction and the air resistance.
Also the air resistance, but not friction.
Oh, this is all my questions.
Alright.
Judges and the competitors. This is a reviewer from Timmy Downing. And today I'm going to review the problem number 7, the rectangle. And this is a problem statement, and the main focus that reported focus on is to investigate the relevant parameters that affect the injection speed. And there is a review of reporter. the report didn't mention that any phenomena, and report say in the field report they mentioned that the shear stress and the shear strength, and they talk about the energy conservation. And about the experiment, the reporter mentioned about the mass. The report discussed on the different mass of the bow and the friction and the length of the lunar. And their conclusion is length of the lunar is when greater the length of the lunar, the velocity will be like slower. And if the friction is greater, the velocity will become deeper. And if the mass of the bow is greater, the velocity will become deeper. And if the extra force is greater, the velocity will become greater too. And there are some pros and cons about the reporter, and I think the reporter have abundant variables, but they have lots of the discussion and lack of the theoretical model. And later is the review of the opposition, and I think the opponent have used an alternative approach, but however they are too overly aggressive of the dismissive. And let's move on to the key discussion of the end. The reporter asks that how is the extra force applied? The reporter say that they're using a bare hand, but the reporter suggests that we should use use the spring or the force sensor to quantify the force, because if I quantify the force, I can calculate the kinetic energy or the energy about the projectiles. And the other question the opponent asks is, does the material of the projectile affect the experiment data? The reporter says there is no impact because they put some oil on the lunars. But we think that the difference in material may affect the ejection velocity due to the different properties of every material, such as if the coefficient of friction is changed and the lunar's Young's modulus is changed. And let's move on to the next key discussion. The opponent asks that what caused the energy loss, and the reporter say that maybe a vibration of the lunars, but we think that the air resistance and friction will maybe affect. And our question is, have you considered the non-uniform bending of the lunar? But according to their discuss, they didn't mention it. But after the question, they both answered. And we asked, do you consider rotation of the projectile? The opponent says yes, it will rotate by the normal force. But I think the normal force will go through the center of the mass, so it won't cause the rotation. And I asked, can the potential energy of the lunar be quantified? They both said yes, but I didn't see any equation. And how is the bow ejected? The opponent didn't answer, but the reporter says it's just like along the lunars. And let's move on to the point that it means. In the theory talk, the reporter didn't mention the deflection of the lunar. I think that's very crucial. And the barometer, the reporter says they didn't quantify the magnetic force. And experiment the elasticity friction of the lunars and the material of the lunars and data analysis, the comparison between the theoretical data and the experimental data and error correction. They didn't do this part, and this is all my review.
All right.
What's the most important factor to speed up the flow?
I think it's the extra force. It's the extra force that applied either like the magnet or by the hands. I think it's yes, I think it's an extra force because if there is without extra force, the projectile will be just like this stuck in the lunar and it will not be ejected. So after I apply the force like this, the projectile will be ejected out. So I think the extra force is the things that dominate the projectile's velocity.
I agree with him, but if the force is always the same, it's the force you add on the position of the ruler. You add on, this is the ruler, and you add on here, you add it on here, it's different. The velocity will be different.
So you thinking of the material or the surface property doesn't matter?
Well, it matters, but that doesn't cost a lot. The main is about the force.
About me, I think the material will have a big impact because if I change, because as I mentioned the deflection, and deflection will use the Young's modulus, and if I change the material, the Young's modulus will change, and the friction of coefficient, like the static coefficient and the kinetic coefficient, will also change. So I think if I change the material, it will have a big impact.
No further questions, I think we can do the scoring. Right, so first, you have one more question? Okay, please.
Probably the post speed are given area on the energy. So the important thing is what's the energy transfer ratio? You apply it, you do some work to the system, but it doesn't overall testify to the law. So what's determining the transfer ratio?
For me, speed potential energy will transfer to kinetic energy.
What's the transfer ratio? Transfer.
And some energy will transfer to heat energy. I don't have a specific value because the energy loss will maybe like the rotation and the friction and the air resistance, like with the different material, like the different size of the projectile, like the cross section area will change and it will change a lot of coefficients. So I cannot just say how the efficiency, but if you are applying like a kind of material like the lunar and a kind of the projectile, I can calculate the efficiency of the energy transforming.
I'm sorry, I cannot tell you the exact number because we need to coordinate the space.
I'm asking what's determining the transfer ratio?
What's determined? Oh, I mean the material of the ruler and also the material of the projectile, and so this causes the friction, and this will affect this transfer ratio a lot.
All right. So we are doing scoring. Alright, for the score for the reporter. Alright, 4, 3, 4, 4, 4. Alright. And let's move on to corner. 6, 7, 7, 5, 7. Finally, the score for the reviewer. 6, 7, 7, 8, 8. All right.